Good evening, my YouTube viewers. In this particular video, what we're going to be talking about is confidence intervals. Okay, so for a 95% confidence interval for the population mean is constructed so that 95% of all confidence intervals calculated from random samples will contain the true population mean. So that's just a little bit of background information on confidence intervals. And I know that we've covered confidence intervals in the past, but we're just going to review them, hopefully to get a little bit more clarity. So we're going to use Python to demonstrate these confidence intervals, and we're going to import 3 Python libraries to do it. So the first library that we're going to import is NumPy as NP, which is the numeric library. And then we're going to import SciPy.stats as stats, which is the statistical module of SciPy, which is the scientific library. And then finally, we're going to import matplotlib.pyplot as PLT, which is a visualization library. So we're going to generate some sample data, which is test scores of students. So the first thing that you want to do is you want to set your seed. And what happens when you set your seed is that every time you run the program, it initializes to the same variable, same values. So it will work the same every time, which is what you want. So you set the seed by typing np.random.seed, and you can put whatever value you want inside the brackets. So the sample size is going to be 50. The population mean is 75. The population standard deviation is 10. And the sample data is going to be a normal distribution. It's going to be np.random.normal brackets. Log equals population mean of 75. Scale equals population standard deviation of 10. And size equals sample size of 50. So now what we do is we calculate the mean and the standard error. So sample mean equals np.mean sample data. Sample standard deviation equals np.std brackets sample data, comma, DDOF, and equals 1. And the DDOF is your degree of freedom. Standard error equals sample standard deviation divided by the square root of the sample size. Now we're going to calculate the 95% confidence interval using the t-distribution. So confidence level equals 95%. Degrees of freedom equals sample size minus 1. So with a sample size of 50, your degrees of freedom are 49. Your confidence interval equals stats.t.interval, brackets, confidence level, which is 95%, comma, df is your degrees of freedom, which is going to be 49. And log is your sample mean, which is the mean of the sample. And scale is standard error, which is the sample standard deviation divided by the square root of the sample size. So now we're going to print the sample mean and the confidence level, confidence interval. So your sample mean is 72.75 and your confidence interval is 70.09 to 75.40. So you can see that your population mean is 75. So your sample mean is less than your population mean. So that just indicates that your population mean and your sample mean are not always going to be the same. And the reason for that is because the population covers the entire group, but a sample just covers a little sample of that group. And that's why your sample mean and your population mean aren't always going to be the same. So now we're going to plot the sample data and the confidence interval. So we're going to plot a figure size of 6, 4, and then we're going to create a histogram of the sample data. So plt.hist bracket sample data, comma, bins equals 10, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7, and comma, label equals sample data. So now we're going to add some vertical lines to the histogram. So plt.ax feedline brackets sample mean, comma, color equals blue, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals sample mean. Then plt.ax feedline brackets confidence interval 0, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower bound confidence interval 0. plt.ax feedline brackets confidence interval 1, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper bound confidence interval 1. So now we're going to add titles to the graph. So the title is 95% confidence interval for the mean. The X label is value, e.g. test scores. The Y label is frequency. You get a legend, you get a grid, and then we're going to show it. So you can see here we have the 95% confidence interval for the mean. The sample mean is 72.75, whereas the population mean is 75. So you can see that the population mean and the sample mean are not the same. The blue bars are the sample data. The lower bound is the green dashed line, and the upper bound is the red dashed line. So that's an example of confidence intervals and how to make your confidence intervals. So the next video is going to be on another statistical topic, and I hope you decide to watch it.